talk about solar hybrid microgrids in Sub-Saharan Africa. This webinar is hosted by JinkoSolar and Elum Energy and will be moderated by DNVGL. My name is Jules Smeets. I'm a principal consultant at DNVGL and also the team lead for energy storage services in Middle East and Africa. So DNVGL is a global provider of services for managing risk in maritime, oil and gas, energy, business assurance, and digital solutions. We have about 12,000 employees, over 100 countries, and we invest about 5% of our R&D in 5% of in R&D of our annual revenues. So I'm part of the energy business area of DNVGL, where we are about 2,300 people working to help accelerate the energy transition. The topic we're discussing today is an important one. It's stepping up to the challenge of supplying reliable and affordable energy in sub-Saharan African countries. I want to share one example of our energy transition outlook for the past year. It's an annual report where DNVGL looks at the most likely future for the energy supply in different regions in the world. And here I show one example of our forecast for Sub-Saharan Africa, where you can see that we expect a large increase of renewable power to go up from about 29% in 2017 to 69% in 2050. And we expect that solar microgrids and other hybrid solutions will play an important role in achieving this. So in today's webinar, we'll have two speakers, one from JinkoSolar and one from Elum Energy, who are working to help realizing this energy transition and hopefully exceeding this forecast. I want to remind you that please post your questions using the control panel on the right. There's a label questions, and then we'll answer these at the end of the webinar. Any questions we can't answer during the online webinar, we'll answer offline and share the answers with you together with the webinar recording. We'll start with one poll question to have an idea of where everyone is coming from to help us in presenting and knowing what questions to expect from you. Just waiting for a minute. Yeah, it seems like all people have answered. Thank you for that. So it's nice to see we have a very large attendance from people who are actually involved in implementing these projects. So project developers and EPC contractors and suppliers and consultants. So I think it's fair to say that we have a good representation here today of people who can make a difference. I will give the floor now to the first speaker today, which is Mr. Mohammed Sadi. He's the Technical Services Manager, Middle East and Africa at JinkoSolar. He will focus his presentation on the latest PV technologies for solar hybrid systems. Mohammed, please go ahead.
Yes, thank you so much, Jules, for introduction. Hi, good afternoon, everybody. Thank you so much for attending our webinar today. My name is Mohammed Sadi, and I'm in charge of technical services for JinkoSolar and Middle East and Africa. And happy Ramadan to everybody fasting today. And today topic is very important for us because we see the big potential of hybrid solar systems in the world, and especially in Africa. And we see it provide a very big value and important solutions to many regions. That's why we wanted to highlight few technologies. And from my side, I will talk about the PV system technologies that really can enhance the performance of the hybrid system and really provide very good, reliable solutions. So just very quickly, JinkoSolar is a solar module manufacturer, Chinese solar module manufacturer, established in 2006. And last year, we were the biggest solar module in terms of module shipments, were more than 14 gigawatt. And this year, we are hoping to reach 20 gigawatt. We have offices in all over the world, and in our region, we have more than 25 people catering the region, Middle East and Africa. We have 3 product series now: the Cheetah, the Swan, and the Tiger. The Cheetah is the traditional monofacial module introduced in 2018. The Swan is the bifacial introduced in 2019, and the Tiger has both options, monofacial and bifacial, which was introduced in 2020. And during the course of the presentation, we will go through on high level detail explanation of the technologies for each one. Of course, the topic of today is the solar hybrid system. We call any system with one or more system power providers as a hybrid system. So it can be solar with any other system like wind, diesel generators, battery storage. So a combination of 2 systems is considered hybrid. And of course, our focus today is the solar based hybrid. So solar can be coupled with the storage, battery storage, with the wind, with diesel generators. From my side, I will cover the solar part, and Victorian will cover the generator diesel part. So we see in general the solar hybrid based solutions to be very convenient to many applications in the world. Because first, it's eco-friendly, of course, it's a green solution, and we see that, of course, the world globally is going into that direction. We see many regulations, not only in Europe and US, but also we started to see it in our region, regulations to minimize the CO2 emissions. So this will be in line of these regulations moving forward and pushing into more cleaner solutions. And we see the investment value now of solar based hybrid solutions has become more and more competitive. So it's not only about going green or going clean, but it's also it's a very feasible solution for developers and for the governments, and we will highlight this a little more. It's also during the peak time, we see the solar system provides a stable and reliable source, because during the peak time is during the day, and the sun is available during the day in our region. So we see that for the poor grids, this will be a more stable solutions and expandable. You can add to it, you can improve it. You don't have to limit yourself on the first initial design. It can be upgraded and modified. You can add more modules, you can add improve, and after maybe 10 years you can do retrofitting for the system, and all this will be applicable if you're using solar modules. And of course, when you compare it to any other solution, it requires minimum maintenance because it doesn't have any moving parts. So the maintenance, this is something maybe in the Q&A we can also talk more. The maintenance requirement for the solar modules is minimum compared to any other solution, and it's reliable. And this is the topic of my presentation today, is how much reliable or how it can be more reliable. And we will cover both in terms of technology and also in terms of durability. So if we talk about the levelized cost of electricity, the LCOE, which is the total cost during the lifetime of the project divided on the total energy generation. And this chart on the right is actually from Bloomberg, where they studied how competitive the renewable energy technologies has become. And during the last 10 years, we see a very big reduction in the cost of the system, the cost of the modules, the inverter, and the balance of systems to around 80%. But at the same time, also, we see the performance of the PV modules improved by almost 100%. So 10 years ago, the mainstream modules were 180 or 200 watt, and now we see at least 400 watt in the market. So by double, so by 100% improvements. So now we see the LCOE for solar has become very competitive, and it in almost now considered 2/3 of the world's solar is competing heavily against the fossil fuel generation. And if you are also considering a battery storage with the solar, also you can see the pink chart here, how the battery also storage has become more and more competitive in the last 7 years, how dramatically the reduction has been done. And we see a few days ago, a new record in LCOE here in Abu Dhabi has been recorded of 1.35, and this 2 gigawatt in Al Dhafra, and Jinko is actually part of this project. So we see the solar technology has become more and more competitive, has become more and more feasible. So it's not only an option, but we think it's a necessity to have a solar-based solution for remote areas, for poor grids, and for off-grids, not only in Africa, but worldwide. The other point is the reliability of the PV module in terms of performance, because most of the peak time is during the day, especially when we talk about hot weather, like what we are, where, for example, in Middle East, we see the high demand of electricity during the day because of the cooling loads. So during this, the solar will be available to provide the load, and so it can be considered the base load. And of course, if there's something extra, it can either go to the grid or be stored by batteries or other storage solutions. So so it is reliable in terms of availability during the day. And during the night, of course, the second load either could be a diesel generator or any kind of storage can be available to fulfill the demand. So very quickly, I will go through many technologies that have proven to be a reliable and to provide a good solutions for especially Sub-Saharan Africa region. The first one is the high efficiency mono, which has become now a mainstream in the industry, or they call it also monoPERC, adding one layer contacts at the bottom of the solar cell to enhance the reflectivity. So this actually has become mainstream, and you see most of the big top 10 suppliers actually offering this as a base technology. So based on that, we see this technology is moving forward, and we see some regions in Africa still preferring polycrystalline wafers, although mono has become, not even in terms of performance, of course, but also even the pricing has become also competitive to the poly. Used to be poly cheaper, but we see now mono, even the monoPERC has become at the same level of poly, because the R&D and all the improvements done in the past few years in production and wafer manufacturing has also reduced the price of mono. So we see now high efficiency mono has become the mainstream in the industry, and it adds so much value, especially during high temperature and during low irradiance, because it reflects more light than the normal wafer. We see half-cut technology is actually has proven to be a very useful technology, where you cut the cell into half and you minimize the losses inside the cell by 75%, and also you minimize the micro cracks when you do that, the micro crack probability when you also go with half-cut technology. Most of our products portfolio as Jinko is half-cut technology, and we see that at high temperature, we see the half-cut performing so much better than the full cell. The bifacial also, if you're considering bifacial, generating electricity from both sides. So this something can be also applicable for many regions, depending on the albedo and the ground. But also bifacial, if you go with transparent backsheet, the one Jinko provides, it can give you a lighter module and better performance on high temperature, because it allows the module to breathe. So you will have a module with lower temperature, operating temperature. So we see also this technology is very applicable, and also soiling effect. It reduces the soiling effect, especially when you are installing in the desert. Two small technologies now gaining more and more popularity is the multi-bus bar. Now the standard is 5. Now we are moving into 9 bus bar, and it reduces the losses in the travel distance for the electrical charge holders. So it reduces the losses. And also we see the tiling ribbon technology as emerging technology now, offered mainly by Jinko, and we see this technology going more mainstream, where you eliminate the distance between the solar cells, and you pile the cells on each other, and you use round ribbon to connect the cells together. This, especially during low irradiance, this adds and gives more performance. And this is the performance part, but another part of reliability, and the most important part, is the durability part. How you can ensure that the solar modules will perform for 10, 15, or 25 years. Now the standard in the market is 25 years. This by you make sure that you have premium bill of materials. This is something you don't see in the data sheet, something you have to do a due diligence, and you have to look for it. Some companies like DNVGL, PVEL, TUV, they all have a reliability test where they test the module at very harsh environments, simulating the 25 years weather conditions, and they issue and they release these kind of reports. So if you have a very good cell, but you don't have a very good data backsheet, then the module will fail. If the anti-reflective coating in not a good level, then you will lose 4% of the generation. So these things, something you cannot see on the data sheet, but it's very important to consider. If you are having modules installed in high irradiance in the desert, for example, high irradiance environment where the UV exposure is high, then you need to have a fluorine-based data sheet like the one from DuPont, for example, Tidler backsheets. So these all should be considered, and now available in the market are reliable modules that can give you a durability for 25 years and a very good performance for 25 years. I had presented what I wanted actually to present and to emphasize on the reliability and durability part of the PV modules and the technologies associated with it. So thank you so much for your time, and thank you, Jules, and back to you.
Thank you, Mohammed. We'll continue with the second speaker today, which is Victorian Delang. He's the sales manager for Southern Africa at Elum Energy, and he will focus more on energy monitoring and control systems for microgrids and commercial and industrial hybrid systems. Go ahead, Victorian.
Hello, everybody. Thank you. I'm really pleased to be here. Thank you, Jules, and thank you, Mohammed, for this introduction and presentation. So yeah, I'm Victorian, Sales and Operation Manager in Southern Africa for Elum Energy. I'm going to start first with an overview of Elum. Elum Energy is a French company with offices in Paris, Casablanca in Morocco, and Cape Town in South Africa. And we plan to open soon other offices in Singapore and Dubai really soon. We are really a global company with now more than 50 sites equipped, more than 30 countries, strong clients all over the world. And we are basically providing monitoring and control solutions for what we call hybrid sites. Elum Energy is operating on different fields and on different type of sites. My presentation today will really focus on the C&I sector, commercial industrial, and on the industries, but we have also products for telecom towers and products to suit power plants and larger plants, utility scale projects. One of our most important value at Elum and what we bring really to the market is our compatibility. We really bring standardization in the process and commissioning of the solar EPC, to really allow them to save a lot of time and money that they don't have to deal with different control and monitoring solutions depending on the site. We like to say that we are hardware agnostic, being able to integrate with the main players on the solar market, being the PV inverters brand, the genset controllers brand, the battery PCS brands, like brands like Huawei and stuff. This is not a comprehensive list. So if you have a specific device you want to discuss about, just ask us directly, and we'll be happy to answer your questions. After this introduction, let's move a bit into concept definitions with what is a microgrid, what is solar diesel hybrid system. So a microgrid is a distribution network that relies on local means of producing electricity, and a focus also on solar hybrid systems that are systems that combine solar power with other energy sources. So it can be batteries, it can be a backup system with diesel generators. And we'll focus on two main contexts, which are pool grid systems in Sub-Saharan Africa and off-grid systems. First, let's dive into pool grid. Oh, yeah, pool grid here. So pool grids are basically grids that are extremely sensitive to load imbalance, with a lot of frequency fluctuation, and actually that's grid that often collapse. That's why you need backup systems. And what of the most people don't know about having solar power on this type of system is that with load shedding happening or with blackout happening, you will actually lose your solar production during these times, because the PV inverters will basically shut down to protect the grid and to prevent from the power to go reverse. So that's the real value that Elum hybrid controller and an EMS is bringing to such type of grid and context. Here is a basic configuration of a grid-tied system with our e-power control. Mainly our e-power control will be wired to the different part of the microgrid, to the PV inverters directly, to the genset controllers. We'll put meters to monitor the genset if we don't have genset controllers. We'll put meters to monitor the grid. And on top of this e-power control, that will really master the site with inbuilt and autonomous control, we'll have the e-power monitor, which is basically a monitoring platform where you will be able to see your data and even to do remote control. But we will talk about it a bit later. In terms of features for grid-tied applications, mostly the main features I want to emphasize on are grid feeding management. Depending on the site and depending on the client, we'll be able to do a zero export feature if the client doesn't want to export to the grid, or we'll be able to export actually if the client is allowed to do so. And also the minimum genset loading features. When the grid is actually down, we'll be able to keep your PV kicking while ensuring minimum genset loading on your site, saving actually a lot of fuels. Some study cases based on basically the quotation request we are getting and classic types of configuration we see for you to have like real examples. For example, we have to deal with a lot of C&I facilities, mainly to mitigate poor grid impacts, so blackouts or load shedding impacts. The first example, for example, these pictures is coming from a wine farm in South Africa, but we have like different type of similar sites in Ghana, in Gambia, in Zimbabwe, and countries and markets like that. The second example is PV integration on fuel station. It's really also really interesting as lots of like major players on the fuel stations market are going green and want to put actually PV panels on their stations across all Africa actually, but also PV to power and to integrate PV and diesel backup to bank facilities in countries like Nigeria, Kenya, and stuff like that. Our controllers can operate on totally off-grid sites also. That's the second configuration. So off-grid sites are not basically, like obviously not connected to the grid, and they are generating electricity from solar panels and other sources. And the goal here for the EMS is really to maximize the solar production and of course reducing fuel cost and CO2 footprint mainly. So same kind of process, same kind of configuration. We would just need here to integrate with a battery PCS on this context. So same kind of stuff will be wired directly to the battery PCS, and our e-power control will autonomously manage the site. In terms of features here, what we can do about that is that we're gonna manage the spinning reserve and do spinning reserve optimization using the batteries. We're still gonna do minimum genset loading, of course. And when we'll have the possibility to apply them, depending on the genset controller on site, we'll be even able to do diesel off mode to make sure that we save even more fuel and we save as much fuel as we can. Some study cases for off-grid configurations. A lot of rural electrification, of course, in countries where people don't have access to electricity everywhere, countries like Malawi, Angola, powering also small towns with PV diesel off-grid, larger sites. We've got cases in Somalia, and also utility scale. Like our controllers are able also to bring value in matching actually grid code requirements and to really monitor and control utility and large scale projects. Other references, but I'm going to be quick about them. In Gambia, PV diesel. In Ghana, Madagascar, Lebanon, you can ask us for more details after that, but I'm going to go quick on it. Off-grid application in islands mainly. And now let's go deeper into our product portfolio and our real value, our real hardware and firmware. In a general way, the core values of our e-power control products are that we'll have a product and a tailored solution for each application that really allow us to be cost effective depending on the device you have on site, on every type of site you'll have. And of course, we sell premium and reliable product that we are really proud of, with a real outstanding service level, and also we'll go deeper into that, but a really easy commissioning and deployment of the controllers. To speak about some of our products that are really relevant to the subject today, I want to emphasize first on our solar diesel controller, which is really a bestseller. It's a PV diesel controller for one genset site, so medium-sized PV, mainly like something around 200 kilowatt peak and stuff like that. That will be able to do minimum genset loading during load shedding, during blackouts, and manage actually the PV at the same time. It's a really cost-effective solution that we are really proud of, and that is already equipped on factories, on shopping malls, on farms all across Africa and all across the world, actually. The second product I want to talk about is the hybrid fuel saver, which is like kind of the big brother of the solar diesel controller, able to do on its side multiple genset management, so multiple genset minimum loading, and deal with more inverters depending on the size. But same way of working that the solar diesel and same features, grid feeding management, minimum genset loading, PV curtailments. And now our MC controller, microgrid controller, that is a very complete controller that will, which will be able to deal with batteries and battery PCS to get actually the best of the PV, the best of the renewable penetration, and to allow you to do, like we said, spinning reserve management, to do diesel off mode if possible. That's a very, very complete product. And finally, the controller that we call PPC, the power plant controller, for utility scale projects and for customized project that can come with a synoptic screen, and that really it's a more powerful product that we've got for really big size projects and customized control strategy. From all of those controllers on site, you'll be able to access to a very nice configuration interface that makes our product really easy to install and to commission. Like the local engineer on site will be able to verify if everything is well wired to the controller. It will be able to set up the internet connection, seeing if the data are coming the right way. Elum is also able to access this platform and this local platform remotely to help you during the commissioning and troubleshoot if there is any issues. So definitely we'll be here to help you during the commissioning. On top of the local access, the hardware and the controller itself you'll have on site, you'll have also, of course, the access to ePower Monitor, which is our monitoring platform that will allow you to perform O&M stuff, operation and maintenance, customize some alarms depending on the inverters, to act on some equipment also for distance. You'll be able to do remote parameter addition. So it's really a remote control that we bring. It's not only inbuilt and autonomous control from the controller. You can even do remote control with this ePower Monitor stuff. And that will really allow you to have customized visualizations of your data to the reports, and that's really helpful. Some screenshots actually about our ePower Monitor. You'll be able to see your different sites. You'll be able to see the active powers from the different devices, from the solar inverters, the inverters operating mode, to see if you get any faults or stuff like that. Edit alarms, of course, which is really important for O&M purposes. And that's all for my side. I hope I've been clear. So I'm gonna pass the hand to Jules again.
Yeah. So I want to thank you, Mohammed and Victorian, for presenting today, and thank everyone for listening in and asking so many questions. We'll still have to get back to you on many of the questions we couldn't answer right away, but you'll receive those answers together with the recording of the webinar.
Thank you very much, Jules, for moderating this webinar. I think it was a great success.
Thank you so much, Jules. Thank you, Victorian. Thanks, everybody.
Thank you, Mohammed.
Enjoy the fasting and see you very soon.
All right. Bye-bye, guys.
Bye-bye.